Alright, this is May the 5th, Algebra 1. This is for 6th and 7th periods. And I've had to reschedule this. I don't know if I'll have anybody watching live. Hopefully, y'all will go back and watch the video, though, and do your assignment. I'm going to get things set up on my laptop so I can see if anyone joins. And then I'll get started. Alright, I can't get everything in view very well, so I'm going to kind of go over the goals, and then I'm going to zoom in on this parabola right here, and then I'll zoom in on the smaller ones. Hey Jillian, I'm pushing things back, but I believe Algebra 2 is still going to be at, it's either 2:30 or 3, probably 3, so check back then. This is Algebra 1. You can watch if you want to, though. It looks a little blurry still. I've been having a little issues with my Wi-Fi again. I think it's okay. Alright, we are for Algebra 1, 6th and 7th period, we've been working with factoring. And factoring involves quadratic equations. Quadratic equations have an exponent of 2. Like a quadratic equation is something like x squared plus 8x plus 7. Or not a quadratic equation, a quadratic expression. Because we're not doing equations yet. Equations would have the equal sign, and we're not doing that yet. We've just been factoring problems like this. It is quadratic because it has the power of 2 in this leading coefficient. And so what we're going to be doing now, since y'all have learned how to factor, is we're going to look at graphs of these quadratic expressions. And then we are going to solve quadratic equations in this lesson. And this may be like the last section we do. I don't know how far we'll get. I would like to do one more unit with probability. Later on toward the last few days of school, but I don't know if we'll get to it or not, because this unit on quadratics is pretty difficult. So you are going to have to wear your thinking caps and listen closely and watch these videos closely. Alright, first of all, our goal. Look at our goal. On quadratic functions, which is our lesson title, we're going to, in this lesson, find the y-intercept, the vertex, the axis of symmetry, and the minimum values when given a graph of a quadratic function. So the whole point in today's lesson is we're going to be looking at graphs. On your IXL lesson, you're going to be looking at graphs of quadratic functions. And then you're going to be picking out these things. if you'll just pay attention to this video and learn your vocabulary, it'll be real easy. There's not anything to work out. It's just a matter of knowing and being able to identify terms on a graph. Sorry about that. The first thing you need to make sure you know and memorize this and know it forever is this term right here, parabola. Not parabola. I believe I called it a parabola one time when I was younger. It is a parabola. And a parabola is the name of the graph of a quadratic function. And it looks like this. It's not a V. The sides aren't straight lines. They're curved. And it's called a parabola. It's more like a U than it is a V. And when you have a parabola, you have certain points on that parabola that are called terms that you're going to have to know. So let me zoom in on this parabola right here. Okay, hang on just a second. Let me get my dog. She is driving me crazy. Can you take her away, please? Yeah. She's barking, she's scratching, she's just being annoying. Okay. Sorry. So here we have, and I didn't label them. Y'all know that's a no-no. There's the Y. It's hard to kind of tell because of this vertical line, but that is the Y-axis. And this is the X-axis. And I have this parabola drawn, which is my graph of my quadratic function. And on this parabola, look at these things that I've labeled and make sure that you memorize them. Your parabola, wherever it crosses the X-axis, has X-intercepts. And y'all have already learned about X and Y-intercepts whenever we were graphing lines. It's the same definition. The X-intercept is where your parabola crosses the X-axis. Now, you're not going to be asked about the X-intercepts in this lesson, but I want y'all to know now that these X-intercepts are going to be found whenever we solve quadratic equations, because the X-intercepts are the solutions. They're the X's to your quadratic equations. So we're not going to be worrying with these today, but we will eventually. The things that we're going to be worrying with today that's in your goal is, first of all, the Y-intercept. The Y-intercept, here's the Y-axis. And I've got it labeled right here. The Y-intercept is the Y-coordinate on that Y-axis where the graph crosses the Y-axis. So that is your Y-intercept. And now let's just take this point right here. This point is 0, negative 1, 2, 3, 4, 5, 6, 7, 8. That point is 0, negative 8. That's the point for the Y-intercept. But if I asked you to name the Y-intercept, it would just be the negative 8, because the negative 8 is on the Y-axis. And that's all you give when you're answering these, is for the Y-intercept, is just the Y-coordinate. Then you also have your vertex. Now, this is a new word, a new term. The vertex is that bottom point on your parabola where the direction of the parabola changes. Like if you'll notice over here, you've got from that parabola, it's going up on the left, and then on the other side, it's got a mirror image going up on the right. And that point where it changes the directions that's at the very bottom on this parabola is called the vertex. Now, sometimes that vertex will be at the very top if it's turned upside down, but it's the very bottom or the very top point on your parabola. That is the vertex. In this case, that vertex is the point 1, negative 1, 2, 3, 4, 5, 6, 7, 8, 9. That vertex is the point 1, negative 9. Now, you're going to have to give the entire point for your vertex when you're answering your questions on IXL. On the Y-intercept, remember, you just give the Y-coordinate. The other thing you're going to need to know is your axis of symmetry, and I've got it labeled here. It's this dotted vertical line. remember, vertical lines are always given with an equation x equals, and then the number where that line crosses the x-axis. So in this case, this vertical line goes through the point 1, 0 right here. So the x-coordinate is 1. And so your axis of symmetry, which is always an equation, and it always starts out x equals, it's just going to be where the vertical line meets that x-axis right there. It's also going to be the same as the x-coordinate in your vertex. But it's the vertical line that goes through your vertex. That's important to know. Alright, now, hey Kayla, hey Blake, I hope y'all are still with me. I need to start giving extra points for people that watch live. Alright, so now, after y'all have seen what the labels are for this parabola, I'm going to move it over and let you see what I've got over here also. Like I said before, sometimes your parabola can be turned upside down like this one. So what I wanted to show you, if your parabola is turned up, your vertex is at the bottom. And that bottom value across on the y-axis, that y-coordinate on your vertex, is also called the minimum value. And it's the IXL is going to ask you for the minimum value sometime. So it's the y-coordinate of your vertex. Now, if your parabola is turned upside down like this one, the very top point is your vertex. And if it's on top, it's the maximum value. And when we're talking about the maximum value, we're talking out of all the points on the graph. That's the one at the top, so it's the maximum value. And then it is also the y-coordinate of the vertex. Alright, so let's go on now to some examples. And like I said, I went through, this is an easy lesson, I went through all your IXLs. Hey, Abby. What is that? That's not my examples. That's not my examples. There they are. That was my list of people that had donated to the Miles for Meals that some of the track and cross-country members are doing. But here's my examples, and let me zoom out. I went through your IXL lessons, and I picked out examples that were just like theirs. So just pay attention closely. You're going to be shown a graph like this one. This is your example 1, and you're going to be given a graph, and then it's just going to tell you what to name. So look at this graph and look at this. I've got two parts, part A and part B. In part A, it says use the graph to name the vertex. Okay, so first of all, read your directions and make sure you know what it's telling you to enter. If it's telling you to enter the vertex, it is going to give you something like this, because you have to enter an ordered pair, and it's just going to leave those two places blank for you to enter the ordered pair for the x-coordinate and the y-coordinate. Alright, so look at your parabola. Remember, your vertex on this one, if it's turned up like this is going to be this point at the very bottom. Now look at the way I counted. I wrote my numbers on the y-axis so you can see I counted by 2s. So that's why that point falls in between right there. That point on the x-axis is -3. That's -3, and then it goes down to -9. Alright, so -3, and then over here, -9. So that's your point. -3, -9. And that's all you do. You just got to make sure you know vertex is this bottom point, and then just name that point. And that -3, -9 is that point. So that's your vertex. It's that easy. Okay, next. Part B. We're using the same graph because I didn't want to keep drawing graphs over and over. On part B, it says use the graph to name the axis of symmetry. Now remember, the axis of symmetry is the vertical line. That vertical line, I don't think I mentioned this when I was showing it before. That axis of symmetry is important because it cuts your parabola into two mirror images. And so every point on the left side matches every point on the right side if you were to fold them on top of each other. So that's what the axis of symmetry does. Now this axis of symmetry, this vertical line that I drew through -3, you would just name it x equals -3. Make sure that you enter the equation. Don't just put -3 in. They'll count it wrong. You have to put x equals, and it's always x because it's a vertical line. And how did I know it was -3? Because I saw the vertex, and I know that the vertical line has to go through the vertex. And so it's going to be whatever that x coordinate is, which is -3. You could just get it by looking at your vertex, the x coordinate. It matches. All right, example 2. Let me slide this up a little. Example 2 says use the graph to name the vertex. This is just, and the axis of symmetry. Same directions, just making sure that you have an understanding of it. So again, look at your parabola. The vertex is this point right here that's at the very top of the parabola. This is my y-axis. This is my x-axis. And that is just 0 right there. So the vertex is 0, -1, because it's moved down 1 from the origin. Alright, so remember on IXL, it's going to go ahead and give you, I think, the parentheses. And then you're just going to have to fill in the x and y coordinates. So again, if the vertex is right on this y-axis, then the x is 0. And then the y coordinate is -1. So 0, -1 is your vertex for this upside down parabola. Alright, then it says use the graph to name the axis of symmetry. Remember, the axis of symmetry has to be in equation form, and you have to type it in, x equals. And then it's just going to be the x coordinate that's in your vertex, which is the 0 of this coordinate right here. So x equals 0. And that is your answer. Alright, let me, before I'm going to example 3, I just want to make sure y'all understand. So I'm just going to sketch a graph right quick. And I'm going to do a rough looking parabola, so just forgive me. This is my x, so let's just say we have a parabola. Well, this is a bad parabola. That's not how parabolas really look, but y'all know I can't draw. And it was supposed to meet right there. Alright, so your vertex, you would say, is 1, 2, 3, -1. So 3, -1 would be your vertex. The axis of symmetry goes through that. Your equation then would be x equals 3. Alright, so hopefully you understand the vertex and the axis of symmetry. So now let's go to the next example. This next example, so easy. The y-intercept. Alright, example 3. Use the graph to name the y-intercept. Here's A and here's B. These are two different graphs. I'm doing one example. The y-intercept, remember, is just the y-coordinate on the y-axis where your graph crosses it. So your graph crosses it, and you don't have to enter an equation. You don't have to enter a point. You just enter a number. So your y-intercept, I'll just put y-int. And it's just, excuse me, it's just going to be 1. Okay, because that's where your parabola crosses the y-axis at 1. So you'll just enter 1 on IXL. Alright, look over here at part B. Where does this graph cross the y-axis? It crosses the y-axis right here at this point. And that is 1, 2, 3. That is 3. So you're just going to enter, for your y-intercept, you're just going to enter 3. Isn't that easy? Wow, there's Dulcinea, Maurice, and Kendall. Hey, long time no see. All right, example 4. Name the equation for the axis of symmetry. So we're going back to that one because that usually gives students the most trouble. I just wanted to make sure y'all could do that one again. And it's going to mix these up, so you've got to make sure you read your directions on IXL. All right, so the axis of symmetry is over here at the vertex. Just imagine a line going through that vertex, and it goes through it at -1. It's on the x-axis. -1. So you're going to say x equals -1, and that's your answer. All right, now name the minimum value. The minimum value that's on the front page of notes. Remember, the minimum value is always going to deal with the vertex. It's going to be the y-coordinate of the vertex. And if it's a minimum value, it's turned like this one is, going up. I think I need to slide that up. If it says maximum value, it doesn't really change how you do it. It's just going to be the graph they give you is turned upside down if it said maximum. All right, so this is name the minimum value. So look at your parabola. Look where it is on the y-axis. It's at 1, 2, 3. So if I told you to name the vertex, which I'm not doing, but if you need to know the vertex for these kind of problems, it's 0, -3. And your minimum value is just going to be that y-coordinate in your vertex. So your minimum value is just going to be -3. That's the lowest value, the lowest y-coordinate on that parabola. So that's the minimum value. All right, moving on. I had to use a lot of graph paper for these. Example 6. Name the maximum value. All right, maximum value. Okay, so you're going to, anytime it's maximum or minimum, you look at your vertex. That vertex is 2, 2. But they didn't ask you to name the vertex. It asked you to name the maximum value, which is just going to be the y-coordinate right here of that vertex. So the maximum value you would enter is just 2. And example 7. Now, example 7, I'm going back and just reviewing everything that you'll have to do in this lesson on your IXL in one problem. And this is going to be the last example. So, first thing it says to do is name the axis of symmetry. So, look at this graph. You need to look at your vertex. Imagine a vertical line going through that vertex and just name what that line is. That line is at 2 on the x-axis. So it's going to be x equals 2. This is the only one where you've got to put it in equation form. So x equals 2 is your answer on the axis of symmetry. Part B says name the vertex. All right, the vertex is this point right here. And that point is 2, like to the right 2, up 1, so it's 2, 1. 2, 1 is the vertex. The y-intercept is where the parabola hits the y-axis over here at 1, 2, 3, 4, 5, and you just put that y-coordinate 5 in. And the minimum value, you go back to your vertex, and it's going to be the y-coordinate in that vertex. You can just look here on the y-axis at 1, or you can look back to your vertex and see that it matches the y-coordinate. So the minimum value is going to be 1. And that's all you do in this lesson. To me, as long as you learn these terms and where they're located on your graph, this is super easy. So I would try to get to a 100 to get some bonus points on this one. But you can see you only have to get to an 80. You're doing Algebra 1 on IXL. This is BB1. We're starting the BBs, which are going to be the quadratics. So BB1, smart score of 80. Try your best to get some bonus points on this. Alright, I hope everyone understood it. Even though there's only 2 Algebra 1 students watching. Hopefully everybody else will go back and watch. And I will see y'all Thursday. Take care.